All right, checkpoint quiz number 1, chapter 3, pre-algebra. First question is to estimate the value of the square root of 85 to the nearest integer. What they really don't want you to do here is they really don't want you to just take the calculator out, punch in the square root of 85, and then write it to the nearest number. That, however, is a way to do that. I will show you a slightly different way. I know that 85 is not a perfect square, but I know there are two perfect squares that surround it, 81 and 100. And the square root of 81 is 9, and the square root of 100 is 10. Since 85 is a lot closer to 81 than it is to 100, I would say 9 is the best estimate of the square root of 85. Most likely punching that out in the calculator, somebody, what is it? 9 point what? 9.2. That would have also given you 9 as an answer, and that's fine. Would I accept 9.2? No, because the answer is 9. It says to the nearest integer, so you would have to go to either 9 or 10 at that point. Okay? So make sure that you estimate if that's the case. Problems 2, 3, and 4 ask to identify if the number is rational or irrational. Square root of 13. Any square root that is not a perfect square, 13 is not a perfect square, will be a decimal that never ends and never repeats, which means number 2 is irrational. Number 3, written as a fraction, by definition, all rational numbers are numbers that can be written as fractions, rational. Last one, continuing on, this decimal 0.23124125, there is a pattern to the decimal, but there is no repeat here. There's a difference between repeating and a repeating pattern. Since there is no repeat here, it never ends, never repeats, we would also say number 4 is irrational. Questions 5, 6, 7, and 8. I'll ask you to find a missing length in a right triangle. We're going to use the Pythagorean theorem, which is written out as the leg squared plus the leg squared equals the hypotenuse squared, or the shortened version using a and b as the legs and c as the hypotenuse, a squared plus b squared equals c squared. So on the first problem, problem number 5, they give us the two legs, which are 9 and 12, and we're trying to find the missing side there, so that must be the hypotenuse, and we'll call that c squared. 9 squared, 81, 12 squared, 144, equaling c squared. Adding 81 and 144, that's 225, equaling c squared. Undoing the c squared, we'll take the square root of both sides, and that gives us the missing side c being 15. Problem number 6, again, we have two legs. So 8 squared plus 21 squared will equal the missing side, which has to be the hypotenuse, since they don't give it to me. 8 squared is 64. 21 squared, I believe, is 441. And that should equal c squared. 64 plus 441 is 505. And when I take the square root of both sides to solve for c, the square root of 405, or 505, excuse me, 22.4. 22.4, do we agree? Yes, no? Square root of 505 is what? 22.4. Problem number 7, a little bit different situation than 1 through 6, in that problem number 7, they give us one leg and they give us the hypotenuse. So in setting up the Pythagorean theorem, which still looks the same, a squared plus b squared equals c squared, the leg 7 I'm going to put in place of the a. The hypotenuse, which is 25, I have to put in place of the c. And so what I'm looking for is the missing letter, which is b. So 49 plus the b squared equals 25 squared, which is 625. I will subtract 49 because my job here is to get b by itself. That leaves me with b squared equaling 625 minus 49, I believe is 576. And then undoing the squaring by taking the square root, the missing leg b is the square root of 576, which I believe is 24. Question number 8, back to leg and leg. So 15 squared plus 19 squared will equal the missing side, in this case the hypotenuse, so c squared. 15 squared is 225. 19 squared is 361, equaling c squared. 225 plus 361, I believe, is 586, equaling c squared. And if someone would help me, the square root of 586? All right, 24.2. And so that's our missing side. Problem, which is in pink, is giving us a drawing of a real-life situation here of a diving platform which is 4 meters above the ground and 8 meters away from where a beach ball sits. If we're standing at this top of the platform looking down at the beach ball, the question is, what is that distance d? Well, as you can see, we've got a right triangle here, and the legs are sides 4 and 8, and the hypotenuse is d. So using our Pythagorean theorem, again, where the a squared plus the b squared will equal c squared, my 4 squared plus 8 squared, which are the two legs, will equal the hypotenuse. I'm going to call it d squared because they use d in the problem. 4 squared is 16. 8 squared is 64, equaling d squared. 16 plus 64 is 80. And the square root of 80 is almost exactly 9, but about 8.9 meters. It is 8.94. Rounding to 8.9 is fine.